Hello guys, today we're going to look at solving a system that has three equations, so there will be three variables. So here I listed off just some steps that will help us solve. So the first step is we're going to take two of our three equations and eliminate a variable. After we've eliminated a variable, we're going to go back to our original three equations and use one of the equations, use the remaining equation that we haven't used yet, along with one of them that we just used. With these two equations, we're going to eliminate the same variable that we eliminated in step one. So after step two, after we've eliminated that single variable, we're going to have two equations with two variables. So then it becomes just a regular elimination problem. So step three, we're going to actually solve those two equations. Okay, so we'll get an x and a y, or a y and a z. We'll get two variables solved for. Then our last step is going to take those two variables and plug them back into one of our original equations to get the third variable. So we're just going to do some examples that'll make these steps make a little more sense. And obviously I put step 5 on here. You can always check your work and make sure that you have satisfied all three of your equations. So here's our first three equations, our first system. So our goal is to get an x, a y, and a z. So I went ahead and took the top two equations. In order to cancel something off, I chose to cancel off the z's because they have the same coefficient. But you have to multiply one of the equations because notice they both have plus signs. So I went ahead and multiplied the second equation by -1, and you can see that here. Then I added them and got -8x minus 2y equals 4. So we're going to hang on to that for a minute, but I have to go back and use this 4x equation along with one of these two. And my goal is to cancel off the z again. So I went ahead and used the top equation again, and now this bottom equation. But again, I had to multiply this bottom equation by -1 so that my z's will cancel. So I did that over here. Here's my top equation, my bottom equation multiplied by -1, and now we're going to add them just like we did in step 1. So once we do that, now we have these two equations and two variables, and we know how to solve those. So I took them and rewrote them right here. Obviously, nothing's going to cancel off between the two. Our y's are closest to canceling off those. So I'm going to multiply my bottom equation by a -2. So you see that here. Top equation stays the same. Bottom equation multiplied by -2 looks like this. And now I add them. So I'm left with -2x equals -2. Solve that to get x equals 1. Plug x equals 1 back into one of these two equations. Okay, so I did that with the top equation, -8 times 1 minus 2y equals 4. Solve that and you get y equals -6. So at this point I have two variables, and we're on to step 4, which says take these two variables and plug them into one of your original three equations. So I went ahead and plugged it into the first equation because there's no multiplying involved. So I have 1 minus 6 plus z. Simplify, add my 5, we get z equals 9. And then your final answer will always be an ordered triple. Instead of an ordered pair, we have x, y, and z, so it's an ordered triple. So there's our solution. Let's look at one more example. So here are our three original equations. You notice here that none of our variables are going to cancel. Okay, I went ahead and canceled our z's again. You don't have to. You could easily cancel your x's or y's, but here I have z's with opposite signs. So I went ahead and took the first two equations, and we're going to cancel off that z. But in order to cancel off the z of these first two, I have to multiply this top equation by 2. So I did that. When you multiply your top equation by 2 and then use the second equation, it looks like this. We're going to add those together to get 11x plus 7y equals -30. Now I go back to my original equations. I must use this third equation. And then I'm also going to use the top equation again. Again, we have to cancel off our z's, and they have opposite signs. So now I multiply the top equation by 3 and use my third equation. When you multiply that top equation by 3, you get this. Added together with our third equation, we have a 12x plus 7y equals -34. So now I take my two equations that have two variables, and I'm going to add those together. Now, before we can add, I went ahead and multiplied this top equation by -1 because you see our 7y's are pretty close to canceling off, but they're both positive. So I have to make one of my equations negative, and I chose to make my top equation. So now I add them together and I get x equals -4. Use this, plug it back into one of these two equations. So I use the top one, 11 times -4 plus 7y equals -30. We solve that and get y equals 2. So we're on our fourth step. We are going to take -4 and 2 and plug them back into an original equation. I went ahead and did the top equation. Again, you can choose any equation that you would like. And I went ahead and solved, and we get z equals 7. So our ordered triple, or our solution to this system, is -4, 2, and 7.